Our lesson for today is based on Mathematics 2611. We are going to look at linear algebra. The topic for today is eigenvalues. This is lesson 101. Let us start. I'm not going to dwell much on the definition of what are eigenvalues, but what is important is to know the steps to find eigenvalues. As we are busy going through these steps, you'll have an idea what are eigenvalues. So these are the steps to find the eigenvalues. The first step, we need to find the characteristic matrix. The second step, we need to find the characteristic polynomial or determinator. Step number 3, we need to find the characteristic equation, and then the last step is where we find our eigenvalues. Now you can see that this is the symbol we use for eigenvalues. Let us look at an example to actually dwell much on these steps. Suppose we have matrix A, which is a 2 by 2 matrix, and then we wish to find the eigenvalues. Remember the first step, we need to find the characteristic matrix. Characteristic matrix is defined by A, which is matrix A, minus our eigenvalue variable multiplied by our identity matrix. We know that identity matrix depends on the matrix that you have. Now finding this matrix, which is the characteristic matrix, we have our A, which is 1, 2, 3, 2, minus and then our identity matrix is 1, 0, 0, 1. Multiplying our identity matrix with this lambda, we are going to have something like this. Then from here we find the difference of the two matrices. It's 1 minus lambda, which is 1 minus lambda. 2 minus 0 is actually 2. 3 minus 0 is 3. 2 minus lambda, we have 2 minus lambda. So this is the characteristic matrix. We are done with the first step. We need to go to the second step, which is finding the characteristic polynomial. Now to find the characteristic polynomial, it's very simple. We simply need to find the determinant of this matrix, characteristic matrix. So the determinant of A minus our characteristic matrix. So we know that the 2 by 2 matrix, to find the determinant, to find the determinant of a 2 by 2 matrix, we simply multiply the diagonal elements minus the diagonal elements. So we have 1 minus lambda, 2 minus lambda, minus 2 multiplied by 3 is 6. From here we can go ahead and distribute. We have 1 multiplied by 2, it's 2. 1 multiplied by negative lambda, it's negative lambda. Negative lambda multiplied by 2, it's negative 2 lambda. And then negative lambda multiplied by negative lambda is positive lambda squared minus 6. Then we have lambda squared. You can see that these are like terms. Negative 1 minus 2, it's negative 3. Then we have lambda. 2 minus 6, it's negative 4. Remember, this is the determinant of a minus. Then from here we are done with our second step, which is the characteristic polynomial. Our next step is to find the characteristic equation. It's pretty much simple. Characteristic equation is the determinant of a minus lambda, our characteristic matrix, then we equate to 0. Since we know that this is actually equals to this, then we can simply say our characteristic equation is this. And then from here, to find our eigenvalues, we simply need to solve for lambda. Now in this case, let us factorize. Now let us find the factors of -4 and -3. Two numbers you multiply, they give you -4. You add them, they give you -3. So you have -4 multiplied by +1, it will give you -4. -4 plus 1, it will give you -3. So the factors is -4 and 1. From here we can see that we have -1 and lambda +4. So these are our eigenvalues. Let us look at another example. Pause the video and work out this question. Play the video to verify your answer. Now remember, we start by our characteristic matrix. This is our characteristic matrix. From here we proceed to find the characteristic polynomial, which is the determinant of this matrix. So it's 5 multiplied by 3, we have 15. 5 multiplied by lambda, it's -5. Lambda multiplied by 3, it's -3. Lambda positive, lambda squared. And then we have -1 multiplied by 1, which is -1. Multiplied by -1, it's +1. Then from here we have 15 -8 lambda plus lambda squared plus 1. Then our characteristic polynomial is lambda squared minus 8 lambda plus 16. Then from here we need to find our characteristic equation, which is simply equating the determinant to be equals to 0. Then let us solve for the eigenvalues. So we have 4 multiplied by 4 multiplied by 4, negative 4 multiplied by negative 4, it's 16, negative 4 plus negative 4, it's negative 8. So these are the factors. Now we have lambda equals to 4. Since you can see that both of these eigenvalues, it's 4, we say these eigenvalues have algebraic multiplicity of 2, since you can see that the very same result repeats itself 2 times. That's it for this lesson video. This is Vaues SJ. Thank you very much.